Hi, welcome to another lesson at EDU Solutions Institute. Now, in today's lesson, we are continuing on the IB Physics syllabus. Now, we're taking a step into section B that is described as the particulate theory of matter. Now, last week's lesson, we culminated the HL topic of relativity, where we looked at the space-time diagrams. So stay tuned this week as we start off with section B of the syllabus, learning about internal energy. Now, in today's lesson, we are just going to learn the basics of what exactly is internal energy. Because before we can delve into energy, matter, we have to learn the basic concept of internal energy. Now, before we would have known that Kelvin and Celsius scales are used to express the quantity of temperature. So these are the units as well as the scale readings that we use to describe temperature. Alright? Now, the particles in objects have an average kinetic energy. And what that means is if we have this object here and these red circles represent the particles in this object, each object is moving at random motion. And because of that, they will have varying speed. Right? So each speed would be slightly different based on the direction that they're going. So therefore, if we want to describe an object's kinetic energy in terms of the movement of the molecules, we focus on the average. So therefore, when we average out all these particles moving, this is the average number that we will use. That average kinetic energy is what we classified as temperature. So therefore, when we use a Kelvin scale to measure temperature, we're actually describing what's the average speed that these objects are going. And therefore, we can find that by EK, which represents our kinetic energy, the bar over it represents the average. So it's the average kinetic energy is equal to 3 over 2 times KB times T. Now we see here that KB represents Boltzmann's constant. And Boltzmann's constant would be 1.38 times 10 to the negative 23. And the T here represents temperature, which should always be in the unit of Kelvin. So therefore, once we multiply the KB times T and 3 over 2, we get the average kinetic energy of a particle at a specific temperature. Because now we see that kinetic energy is affected by the temperature. So therefore, if we have a high temperature, that's telling us that the object has a high kinetic energy. If we have a low temperature, then that means the object or the particles in the object has a low kinetic energy. So therefore, what exactly is internal energy? Internal energy is the sum of the total molecular potential energy and the total random kinetic energy. So remember, this was for the average kinetic energy. So therefore, if we want to find the total internal energy, then we will have to find the total kinetic energy, which would be, in essence, just adding how much particles this object has, which we will denote by a capital N. So this will give us the total EK. Alright, so we're adding how many particles are there beside the average. And that gives us a total kinetic energy. and the total internal molecular energy, add those up, and we get the total internal energy. And just to note, the potential energy of particles is basically the energy between the particles. So therefore, as when the particles go further apart, their potential intermolecular potential energy actually increases as well. And if they are close together, then that means their intermolecular particle is very small. And therefore, that's one way how we can distinguish between solids and gas, or solids and liquids, liquids or gas. Because solids will have a small intermolecular potential energy, while gases have a larger because of their spaces between or particles. Now, that's the end of today's lesson. I hope you understand what internal energy is, because on next week's lesson, we're going to take this a little further to learn more on the nature of matter. So stay tuned as we explore more on our IB Physics syllabus. Thank you.